Good afternoon, everybody. My name is Ravi Neelkant. Before I start, I just want to introduce Bala, the EMC counterpart, and John Kennedy, the Cisco counterpart for this VC presentation. Before I start off, obviously there is this whole thing about enhanced business continuity, but this is, for all practical purposes, an extension of what we started off last year as long-distance vMotion. So, show of hands, how many would be interested to do this in your data centers if it's available today? How many are doing simple vMotion inside your data center? That's better. So it's like we're taking the same concept and extending it further across data centers. That's the idea of this solution. And unlike most of the stuff that has been talked earlier in VMworld about workload migrations or futures of cloud migrations and futures, I would say most of what you see here is working today, is supported today. It's not anything new. What we've done here is we've architected a better network and a better storage to use the vMotion of existing capabilities of vMotion to push it to that limit. So, again, from a usual legal thing, whatever I talk about the futures is future. Nothing to do with what we have done. From an agenda standpoint, this is what we're trying to do. Obviously, vMotion across data centers, the use case is not just vMotion like what it is within data centers. It's being used, at least it is being positioned as something to do for business continuity and I wouldn't say disaster recovery, business avoidance or disaster avoidance scenarios. It's not meant for something lesser than that. So if you look at the agenda, we are saying first of all, we need to choose which application is suitable for mobility. And then once you do that, what are the things you need to do, make sure that that application can actually be highly available between data centers. A quick, I would say more than a 50,000 feet view of what is a business continuance plan. Involves your HR, facilities, making sure that you have skilled people on both sides of the data center, supposing one goes down to pick up the other, and you have enough space to do it. And the reason why I put that probably at the top is one of the unfortunate things of what happened in 9/11 was that a few of the financials had their disasters in the two towers. Unfortunately, they lost, God forbid, they lost the people along with the data centers. So that is something which is a part of this whole business continuance plan, which a typical business continuance planner would take care of in considerations. Space, personnel is a part of it, built around a whole bunch of processes and procedures, which will make your business to come up in the event of a disaster or an event of a business continuance event. And finally, to support all that, an IT infrastructure that would do it. That is one of the elements of your business continuance plan. So if you look at the IT infrastructure itself, we are looking at the physical servers. Here, the three pieces of what is there in your server architecture or a server side of the things, the network architecture and the storage architecture to do it. From a challenge for the IT, because here we're all doing the IT piece, we're not doing the first two parts of that business continuance plan. We're looking at more of the IT challenge. What is it that makes it a challenge to attain business continuity? It is, to start with, applications have to be DR aware, or in other words, most of your applications that you want to make sure that it's highly available on the other side should be either cluster aware or some sort of custom DR capability need to be built into that application. From a server perspective, you obviously have to plan for that extra capacity in that other side, whatever that capacity is. If you say during a disaster, I'll run my business 50% degraded, that means you need 50% of the CPU capability on the other side. Similarly, from a network perspective, I think network and storage plays a key role in this. One is your IP connectivity from the outside world should ensure that you go to the other side. If you do, make sure that your security is good enough. That is also the key. And of course, after all that, the last part is probably the most critical piece. Data needs to be there. You need to have data at the other side. Once you do, assuming that you can do all this, or you have an IT department that can take care of all this, in the event of a disaster, business is still disrupted. So it is a disruptive process. So you spend all this time, effort, and money to get all these pieces in place, but you're still looking at an RTO, you're still looking at an RPO within your business plan. It doesn't change. What are we trying to achieve with application mobility? So if you break it down, like if you break down your business continuance events, you have a bunch of events on the top which we would say are planned events, like data center migrations, data center management issues, capacity management, if you want more capacity to bring up another server. All these are planned events, including the last one, which is sort of a new sort of a phrase that we've sort of coined in the last year, which is called disaster avoidance, where we're saying, you know a disaster is coming, can I mitigate that risk? So all that is a part of what we call as a planned events within your business continuity plan. And of course, the last one, in the case of a disaster, obviously you have to restart, you have to recover, you still have a downtime in the data center, which does not change whether you do application mobility or not. So that is primarily what we're trying to address. What we're trying to address in this first phase of this solution is the top 4 bullets. Our idea is to take all the planned events within the data center and take your downtime for planned events and bring it down to the very minimum, if possible, to 0. So if you look at the SLA of your data center, because of what we've done, your data center uptime SLA has gone up tremendously. And that's not just that. If you look at your operations side of your data center, where you have a whole bunch, if anybody who's managed a data center or is part of the IT team here would know that if you have to take a server down for maintenance, you have to go through a whole bunch of change management procedures to just get that approval, because the application is going down. But now if you move the application over to the other side or to another server or to another data center, you pretty much have access to everything in this data center because the application didn't go down. So it gives you, from an operational perspective too, which is like I would say an intangible benefit. It's like it is a benefit, but you can't quantify that benefit. It is there, and you can take that and start working on that. So that is what this whole presentation is all about. So obviously we talked about all this. We said what is the advantages of it? Obviously increase in SLA, distributed applications, business continuance is obviously a part benefit of it. And I think the key benefit is this. Legacy devices and applications are now mobile. The third bullet, which says you can take applications that are not DR aware, that are not clustered, that are not specially written for any business continuity purposes, and move them over and make it available with this solution. And eventually, cloud computing business models. Tomorrow, when your IT starts saying, hey, I want to go to this other cloud or other third-party cloud that I want to do it, what we are building here is a basic infrastructure that is necessary to do it. We've been talking about this. Obviously, as I said, the key thing here is should I take the entire data center on one side and start moving everything over to the other side? Or should I be picky about what I move? If I want to move the entire data center to the other side, it's not going to be so straightforward. It's going to be an issue because of the fact that you're talking about hundreds of apps. You're talking about hundreds of different types of apps, multi-tiered, single-tiered, no tiers, some legacy apps and things like that. So the key thing is you need to choose what you want to move. What is the criteria for choosing? If you look at a data center or an IT operations today, there are at least three different architectures that are prevalent within the data center. You have an application architecture, you have a network architecture, and you have a storage architecture. The reason I put it as three different pieces, those are the three pieces managed by three people. You have the application architecture sort of managed by your server admins and virtual admins or VMware admins. You have your network architecture managed by your network admin and the storage architecture by the storage admin. And then you have your application dependencies. Some of them are tiered, some of them are non-tiered, some of them are legacy, some of them are not. And eventually, all of this feeds into the last one, which is there are multiple business apps, each of them feeding into each other to eventually provide the business function within the IT department. So if you look at it, I just took an example. This is of a telco. Whoever is sort of familiar with a telco, these are the business applications within the telco. At the top of the operation, you have customer requests coming in for maybe provisioning new lines or new phones or whatever. And in one side, you're getting all the network call detail records of all the calls that were done. So those are the two inputs that is coming into this business of what is called as telco. And there's a whole bunch of different applications that is running within this operation to eventually develop the revenue for the company. So if you look at it this way, all that I have to protect for my business to be profitable, like not to lose money when a disaster happens, is obviously I have to protect the inputs coming into the data center and some of the key operations like the CRM coming into the global information system, because somebody calls 911, I need to figure out where that call is coming from. And that is what is provided by the CRM and this one, and things like that. So once I identify that, it becomes easy to build a business continuity plan. Or in other words, if you look at it from an outside perspective, this whole thing is a black box. There are some inputs coming into your IT and some revenue being generated. As long as you make sure that happens, from an IT perspective, you're okay. The minute that revenue generation stops is when everybody comes and says, why did it happen? So primarily, that is the first step. And the second step is take a look at the application architectures. This is a generic application architecture. I picked it out of a paper of Oracle, which is even today, it may not be exactly the same, but it's most of the tiers are the same. You have the client tier machine where the application client is accessing the data. You have the web tier, you have the business tier, and you have the backend database tier, which is typically the same. The names may change. Instead of enterprise beans, it may be some WebSphere server or a Tivoli or a TIBCO server. And instead of JSP servlets, it could be something else. But it's still the same tiered approach to things. Keep this in mind because this application architecture pretty much matches the functional view of a data center. A typical data center, you have the demilitarized zone here on the top, which has pretty much all these functions built into this demilitarized zone. And then you have the business logic tier where you have the application servers, which could be a Java app server or a WebSphere or a TIBCO or a Tivoli or any one of those things. And of course, from the other side, from the mail and other pieces, there are things that is part of the messaging tier of your data center. Backend is your storage tier, or sometimes in the data center world, it's also called Area 51 because that's the most secure part of your data center. Because by the time anybody comes into that, any request comes into that layer, they're supposed to be authenticated through all those firewalls, making sure that they're actually the people who should come in there. So this is what is a typical functional view of a data center. This is from an application side, or you could even say, since it matches directly to the application architecture, it could be that. Obviously, there is two more things that is, as I talked earlier, two more architecture that maps with that. You have a network architecture and a storage architecture. So on the right, you can see the mappings that has gone into the network architecture and the storage architecture. A typical Cisco three-tier network with a core aggregation and a set of access layer stuff. And the bottom, you have the storage area network SAN sitting at the bottom. This is probably the mapping which would exist in any given data center for application versus the physical infrastructure. So now that you know this, how do I pick my applications? Because you know the application side of the architecture, you know the data center infrastructure side of the architecture. You now have to pick which applications to move across. Obviously, the top two tiers in your data center is already network load balanced. There are elements within the network that does that. For example, there's a web server farm sitting here. It can be easily, HTTP can load balanced across the data center to another one. It's already done. Take all your application messaging tier apps. They are statefully clustered, and that cluster can stretch across a distance. It's already there. The most difficult piece is your piece at the back here, which is to attain availability. That is the most difficult piece. That is the tier that would be suitable for your mobility of application. What does it give in terms of doing it there instead of doing the entire data center? The advantages that it gives from an application perspective, non-legacy, or legacy apps, or non-HA aware or non-cluster aware can now be moved across easily. From a networking compute, of course, you now have the capability of using both the CPU powers in both the data centers to use it for your data center. From the network, which is probably where you'll get the most of your pushback if you try to do it as a business continuity planner, is my security is compromised. I can't do it. It's not true, because we're only taking the tier that is the most secure tier in your data center and extending it across to the other side. Because by the time any access comes into that tier, even on the other data center, we are going to repeat the same network infrastructure there. By the time any access comes into that layer, they are authenticated. So there's no changes in security policies. Both the data centers will have the same security policies. There's no changes in how you architect your network. It's still the same. It is just that we take a few VLANs in that bottommost layer of your data center and move it across. We don't move everything across. And from a storage perspective, because we're using active storage with EMC vPlex, you don't need for that particular set of applications, you don't need any other replication method, because it's already being replicated. It's active replication, and it's happening already. So it's sort of, as I said, this probably now people who've been in the data centers can now see like how it brings down the operational part of the data center. Because once you set up this environment, most of the operational pieces like storage replication is part of it. Security becomes part of it for business continuity. You don't have to do anything extra. So from an infrastructure requirement perspective, what is it that is required? So today what we did was we took two Vblocks, which is basically the unit of what VCE sells. We brought up applications on this Vblock using VMs, and with the Cisco data center interconnect in between, you can move VMs across data centers, across two Vblocks seamlessly without any issues. This is what we have actually done today. And what is it that we tried to achieve was this. Today, as of as of today, that is what I say, VMware supports up to 5 milliseconds round-trip time between the two ESX hosts. And one thing we didn't put here is probably what is the minimum bandwidth required. The minimum bandwidth today, as of now, without any WAN optimization, is an OC12 line or a 622 megabits line. That's what we support today. And what it gives you is, it gives you the ability to move workloads between the two data centers at the granularity of one VM or one VM app. And I think this is probably the most important thing, is no downtime when you're doing this, because you're taking a VM and vMotioning it over to the other side. So the application is alive for the whole time. It doesn't change. It's the same vMotion that you're doing it within the data center. And of course, no VM reconfiguration necessary, or in other words, there's no re-IPing, redoing the IP on the other side to bring it up and things like that. So no VM reconfiguration is necessary. So if you look at it you step back and look at it from a very, very high-level picture, this is what it is. You have some sort of extension of VLAN between these two data centers. You have some sort of storage extension between these two data centers, which is in this case Vflex. And in this case, we have multiple technologies, Cisco technologies that can do it. And we have some sort of technology that a client sitting outside here is talking to a system here. When this VM moves over here, it will be redirected to this data center. So all this is part of the solution. We have integrated it with multiple pieces or multiple products of Cisco and EMC to do this. So primarily, these are the three things. IP routing and services is taken care of. VLAN extensions is taken care of. And storage extension is taken care of with this solution. From an overview perspective, this is what it is. If you look at the lab that we built, this from a logical perspective, this is how it looks like. We have the two data centers with the core ag and the aggregation and the access layers with Cisco OTV, the overlay transport virtualization in between, doing from a very high, that's what I said in the morning to people who were there in the booth, it's a very high level selective MAC routing from one data center to another. Only the MACs that are allowed to go on to the other side is moved on to the other side. And then from the distributed switch perspective, we have a distributed switch spanning the two data centers. That is the ESX or the VDS, vSphere VDS or the Nexus 1000. One of them will work. And then at the bottom, you have the distributed volumes being provided by Vflex. So from a component perspective, here is what it is. We have, I think for this, I'll call up John to continue with this, because he is the person who is working very closely with VCE and the Vblocks to start off on this. John, stage is yours.
Okay, good. Hey, hi. My name is John Kennedy. I'm one of the gang of three here, and I work for Cisco. And for a time up until very recently, I was working with the Vblock product management team. So I got a little bit of insight into what Vblocks are. One thing we should probably tell you is that we did not test this particular solution with a Vblock, nor is it certified by Vblock product management to work with a Vblock. However, it works. And we want you to know that we're working very hard to get it certified. I can't tell you about all the internal machinations that we have to do to get that to happen, but it's going to happen. As I'm fond of telling Bala, the Vplex freight train cannot be stopped. But anyway, that being said, we'll talk about what we could be doing. Basically, we've got a stack of network compute and virtualization. That would be vSphere with the UCS system and, well, the UCS system. That's the compute and network. And then on top of that, of course, we have applications and operating systems and all the stuff that you really want. And what we're trying to do or get connected is two of them. hopefully, 2 in different data centers. 2 within the same data center, actually probably not that much of a challenge. 2 in different data centers separated by some kind of latency, and that's what we're really talking about when we talk about distance. We talk about latency. Latency is the real problem when you're trying to do a vMotion, not distance. How many people live around here? Couple? I live down by San Jose. There's an airport down there, San Jose International Airport. It's faster for me to get to El Segundo down by Los Angeles than it is for me to get to Moscone Center, 60 miles away. The reason being, the freeways between here and there are always jammed up. But I can get a flight from San Jose. If I come in 45 minutes before the flight, get on board, the flight takes about 45, 50 minutes, well, nowadays maybe an hour, to get me down to LAX, go through the trains, planes, and automobiles to get to my car, and I can be in El Segundo in an hour and a half, maybe 2 hours. Up here, it could take me 2.5 hours just to get here. The difference being, the pipe I'm traveling through is faster. Make sense? Now that equates back to what we're talking about between 2 data centers because of latency. You might have a very slow pipe between here and San Jose, but you might have a much faster, bigger, higher bandwidth pipe between here and someplace like Raleigh. But eventually, latency gets you. You can only go so fast. The speed of light has a certain maximum that we have yet to figure out how to exceed. Latency is what jams and bollockses up vMotion. So that's what we're trying to get across, is that little cloud right there. Now, the components of this architecture that we've put in, and this is the reason that we say, yeah, it's not validated, yeah, it's not allowed, but it will work, is because these components all exist to interact with each other and have been shown to interact with each other. The MDS 9000, which is what we used in our testing, the Nexus 1000V, the EMC, I guess I always call them just VMAX, but it's Symmetrix VMAX. Bala will go into more detail about that. And a new product called Vblocks, which will definitely raise the hairs on your arm when you hear about it. If you haven't heard about it before, you will like it. It is cool. And then some new things from Cisco, like overlay transport virtualization to make one big, huge network. Global site selector and the application control engine to help redirect things. But I'll talk about those in a minute. All these components work together. Now, of these components, a vBlock contains these, along with UCS. So the only reason it wouldn't possibly work with UCS or with vBlock is if it didn't work with UCS, and believe me, it works with UCS. So, why do I keep saying that word over and over again, a vBlock, 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 vBlock? I'm required to say that a certain number of times during the presentation because EMC paid for me to be here. I'm sorry, Acadia paid for me to be here. A vBlock is, the whole idea behind a vBlock is sort of like your laptop. Everybody's got a laptop of some kind, someplace, right? It is compute, storage, networking, all combined into one easy-to-use package. You know exactly what it will do. It's been tested. You know what it will not do. You know what its limits are. That's a vBlock. We took UCS, EMC storage, and Cisco networking, and put them together into a package and called it a vBlock. It has single phone number support. You don't have to call EMC or Cisco or VMware, depending on which one broke. You call one phone number. We'll take it from there. That's the whole idea behind a vBlock. Now, the benefit to that is that you get all of the benefits of the individual components, but you also get the synergy, the components combined. Because like I said, we've tested it to see what it will do. We know how many virtual desktops it'll run. We know how many Oracle instances you can run on there. We know, we've run SAP on there. We can tell you how that's going to perform. Everybody remember when Intel broke vMotion? Remember that? They came out with a family of processors that had individual different steppings. And so the processors looked just different enough that vMotion wouldn't happen. And then they had to come out with enhanced vMotion, which is a way of ignoring the differences between the processors so that vMotion could happen again. A lot of companies bought processors and bought servers based on those processors, then found out they couldn't do vMotion. That doesn't happen with Acadia and with Vblocks, because we test those things and let you know about them before you buy. So, validated platform, thoroughly tested, and single phone number support. That's the essence of why you want a vBlock. There's 3 types at the moment. Everybody's always pushing for a type. And they're not really, as the vBlock product management likes to point out, they're not what you call small, medium, and large. They're small, but then there's large, and there's larger. And they're really designed for different types of workloads. Vblock 2, 3,000 to 6,000 VMs, it's a bit of a wag. Depends on, obviously, those of you who've ever worked with VMware know that, you can't say, yeah, it'll do about 3,000 VMs. Well, 3,000 what kind of VMs? 3,000 desktop VMs? 3,000 MS-DOS VMs? 3,000 what? 3,000 Windows XP VMs? What does that mean? But that's a pretty good guess, somewhere between 3,000 and 6,000, depending on what you're running. The differences are primarily in the bill of materials that comes with them. And I think I mentioned all of these, the different architecture pieces, but just to make sure I hit them, it's the UCS family, of course, because there is no better platform for virtualization. And I say this with all the credibility of someone who never worked at Cisco until last March. As far as networking goes, really, I shouldn't even be talking about it. Networking. The lobby ambassadors at Cisco know more about networking than I do. I'm from VMware originally. I was there for about 8 years. I have never seen a platform that runs VMware as well as UCS. And there's 100 different reasons for that. You can ask Ed Bugnon or any of the sales reps or any of the V specialists. They'll tell you all about it. The Nexus MDS 9000 series is for storage networking. That way you can attach to your SAN. We kind of need one of those because in UCS we have a 6100 system that is sort of that's the converged fabric, and it can do storage networking, but it's not particularly robust. The MDS 9000 is. Storage, naturally, EMC symmetrics. We're going to reach for the best. There's also Celeron and Clarion, Clarion being in the Vblock 1, and the Celeron being in Vblock 0 for those who are into like NFS. Some people are. But again, Bala will tell you all you want to know about that. Of course, for virtualization, we're using vSphere 4. You know, it's funny. Everybody wants to buy the perfect car so they can modify it. You know what I mean? So they can trick it out. And people buy Vblocks and they want to change it. It's perfect if you just change this one thing. People want to put in, can I swap out the EMC storage for like HDS or something? No. You can't. If you do, you cannot call it a Vblock. You cannot call us on the phone and ask for support. We will not take your call. Can we swap out vSphere 4 and run Oracle straight on the disk, on the hardware? Can you do it? Sure. Are we going to take your phone call? No. It comes with vSphere 4. It's what you want. And, of course, we're coming up with is UIM2 out yet? It's out. Thank goodness. UIM2, Chad Sakich has probably already done an awesome demo. Matter of fact, I think he did it this afternoon, of Unified Infrastructure Management Framework, version 2.0, which is just the most fabulous thing for partitioning a big piece of hardware like this. When you look at this and you go look at it in the VCE, the VCE Coalition booth, it's big. And it's a big workhorse. And you might want to partition it down so that individuals can use different pieces of it. Nothing better for it than Unified Infrastructure Management software. Okay, who knows what vMotion is? You don't have to be a PhD. I mean, you know what vMotion is, right? You're moving a VM with a workload from one server to another while it's running without disconnecting anybody. Easy as pie, right? Okay, so what are the requirements? Somebody tell me. There's a handful of requirements for vMotion. Anybody, tell me anyone. Hardware? You want to be more specific? Matching processors. Thank you. I was looking for that one. Okay. Shared storage. That's a very good one. Okay, you said? Same network, and you said shared VLAN. You're getting warmer, but you're not quite there. Bandwidth? We'll talk about that shortly. Surprisingly, no. Same subnet, thank you. That's where I'm going. Other people call it L2 connectivity, VLAN connectivity. What it boils down to is if you took anything, take your laptop, and you put an IP address on it and make a static IP, and then you take it to a different subnet, you're disconnected. Nobody's going to find you, and you're not going to find anybody. Got the wrong default gateway, got the wrong mask, don't know how to find anything. Same thing with vMotion. Got to have that L2 connectivity. I'm glad that somebody finally came up with that, since it's the first thing listed on the slide. Right. So how do we do that across a large, big chunk of latency? How are you going to do that? Very small in here is OTV. This is a technology from Cisco called OTV, Overlay Transport Virtualization. Me not being a networking guy, but I'm a server guy, so I know enough about networking to tell you whether it's my server or your switch that's not letting me get to the internet. Right? I can tell you that much. I think of this as basically a software version of a piece of cable. That is, when one node is attempting to find another node, and they're on different subnets, obviously they go through what? Default router, yes, right. When they're not on the same subnet, they go through the default router. When they're on the same subnet, they send those ARP broadcasts, ARP, ARP, ARP. I'm ARPing for this IP address, and then whoever has that IP address ARPs back. Now, if they're not on the same switch and they don't have L2 connectivity, they're not going to find each other. And that's a common scenario when you have two separate data centers. So what OTV does is it spans over that gap between the data centers. And when one node is trying to find a node that OTV knows is on the other side, OTV will answer for it and conduct the ARP request across. Now, there's a lot more technology built into that to prevent ARP storms and things like that. I'm getting qualified to talk about it, but I'm not completely up to it. So if you want to talk about it in depth, I'll talk to you, or I'll find somebody who can really talk to you better about it. But that's what we did. So that's how we span that gap. Now, another problem that happens is you just took this node and you moved it from one data center to another, but it's still routing through the first data center to get to the second one. That doesn't do you much good if the first data center gets wiped out. So we had to have some way to change the routing in some fashion. There's a lot of technologies out there to do that, and honestly, our solution is not the best, but it works somewhat. We used a thing called GSS and ACE. Oh, I am on the right slide. Yay! GSS and ACE, basically what they're doing is they give you a virtual IP address. That is, you want to talk to this guy down here, sql-server.jsmp.cisco.com. So you're going to look that up in DNS, and you're going to get an IP address. But it's not going to be the real IP address. It's going to be a fake IP address given to you by GSS and ACE. And you're going to commence to routing to it. Now, that virtual machine is going to move in a very seasick-inducing fashion to another data center. And now you've got to route back through this cloud all the way back here. As long as you are connected to it, you're going to go following that green ball. Now, what happens when the next person goes to connect to it? GSS and ACE were set up by us so that when the next person connects to it, they route through here. In the eventuality that you would lose that data center, in the eventuality that you were to lose this data center, this person would be definitely disconnected. They would have to reconnect. But they would not have to reconnect just because the app moved from here to here. The routing is suboptimal, but it's there. Now, we are working on a better solution for that. But we're just telling you, this is what we did for our testing. And we're going to tell you what we came up with. Now, I think I'm into the SAN portion, so this is probably Bala's turn. You got a mic? Okay, cool. So I'm going to hand it over to Bala.
Can you hear me in the back? Yeah, I guess so. Thank you. Thank you, John. So we talked about the networking piece and also the infrastructure piece and why you're doing the business continuance or the long-distance vMotion. One of the pieces that was mentioned by Ravi when he started it is the important piece is the shared storage, that you have to have the same storage across multiple sites for you to do the vMotion. And one way of doing it, obviously, is the new technology that we introduced about a few months back called the Vblocks technology. And what it does is that it presents a globally unique namespace to any nodes, any ESX server, or any operating system that's actually connected to it. So even though your physical storage may reside across multiple sites, it appears as if it's the same storage whether you access it at site A or site B. And that's one way of actually extending your storage entity so that it is visible across multiple sites as a single entity. Okay? And that's done by Vblocks. And the Vblocks technology manages the storage and the details on where actually the physical storage resides and how to access the right set of devices to perform any operation that's being generated from the host. And that actually is a very important piece to ensure that we can do this vMotion across distance in the vBlock type architecture. Okay? So in the example I've given, I have this virtual machine that is accessing the VMware file system, which is actually residing on this globally unique namespace or a virtual volume that's being presented out to this cluster out here and also to the cluster on the side B. When the IOs are actually done by the VM, it will actually go to this particular Vblocks director that is shown in this picture, and then it will be sent to the devices out here, the physical storage out here at the bottom, and also replicated to the physical storage on the other side. Okay? When the VM moves, like I've shown in this example, the IOs are actually handled by the Vblocks directors out here. The VM doesn't understand that the IOs are actually being sent to this side and to this side at the same time. If it does a read, it will actually read the data. The Vblocks directors will read the data from here and then present it back to it, in a way masking the latency introduced by the system. Okay? So that's what really Vblocks brings into play, is by federating the storage, and we call it federation because we are taking physical storage at multiple sites and making it appear as if it's one entity. And that is a very important piece for this overall vMotion actually to work properly across multiple data centers. So as I mentioned, this is a new federation platform. It takes multiple physical entities and presents it as one. And the most important thing that it provides over some other solutions that we have is that it provides concurrent read-write access to storage devices from multiple sites. In the first release, it's at 2 distinct locations. The goal is to make it as if you went to Chad Sakach and Beth Phelan's talk earlier this morning, she talked about the roadmap where we are actually looking at extending this to more than 2 distinct locations. But at this point in time, it is concurrent read-write access at 2 sites. And that allows for things like data mobility and improved resiliency to unplanned outages. Okay? So there are 2 flavors of Vblocks that we provide. There's a Vblocks local. It's targeted for a single data center type solution. And then there's a Vblocks Metro, which essentially is Vblocks directors or Vblocks clusters across multiple sites. And this is the one that we use for all the joint validated infrastructure that we're going to present in a second. So what does the validation actually look like? This is what we actually set up and tested and proved that it works so that you as a customer can go ahead and deploy it in your environment. So we had the ACE pieces, we had Catalyst and Cisco and Nexus switches. We were running the DCI, the Data Center Interconnect, which included the OTV piece. We had Vplex in the system. And in addition to that, we had VMware vCenter. Obviously, the vBlock had the components of the UCS, the compute, the storage pieces, which was the vMax, and also we had the Vplex into the system. Okay? So this was what was validated, and what was actually used to validate this architecture, so to prove that the long-distance vMotion actually works. So we wanted to use something very realistic. We didn't want to just run some random applications. So we had the Dell DVD Store, which is a 3-tier type application, similar to what Ravi had presented earlier in the initial introduction on why to do application mobility. He talked about three-tier infrastructures as being used commonly, three-tier applications being used commonly. And we use Dell DVD Store, which mocks or is very similar to a three-tier application commonly found in enterprises. Now, one thing I would like to point out is Dell DVD Store. If you're using VMmark and tools like that to actually validate your VMware environment, the Dell DVD Store is now included as part of VMmark. So the application that we are using really represents what happens in real customer environments. And the application, obviously, this Dell DVD Store uses a SQL Server in the back end. We had a 64-bit running as a VM on a 4.0 environment. It had 8 virtual CPUs, 8 gigs of memory, and then obviously we had Vplex Metro that I already mentioned. Okay? Given this particular setup, what we were observing is the transaction, the orders per second that can be handled by this specific setup that we had, and the impact to that orders per the transaction rate when we do vMotion. Number one, whether we lose connectivity, right? That's an important thing. And if you don't lose connectivity, if there is any impact to the orders per minute, which is what you as an end customer, you care about the transaction rate that can be supported, whether there is any impact to that. That is what we were going after when we did the testing. And here's a quick summary of the results. What you will notice is that the top blue line is the actual transaction per second we were processing on with the Vplex in place. And you will see that when we moved it from the 0 kilometers to 100 kilometers, which is about 5 millisecond round trip time, the transaction rate dropped by a very small number, less than 300 transactions per minute. So the DVD store wasn't impacted at all. When I took the VM, which is actually running the SQL database, and then moved it across site, all the way 100 kilometers away, 5 millisecond round trip time, the clients obviously got redirected from site A to site B, and the transaction rates really dropped very little, basically nothing. Right? It's well within the margin of error. Now, to compare and see what the impact would be if you are trying to access the storage across the site, we also conducted the same test using the Vmax array, which was the physical storage that we had in the back, to see what kind of impact that would be. So what this represents, the line in orange, is that the VM actually moved. This is at site A, the VM is at site A, and it has 15,000 transactions it can support. And in this particular instance, the VM is at site B, accessing the storage at site A, 100 kilometers away, right? So there is a latency involved in every transaction that comes through, and the impact is significant. I dropped from 15,000 transactions per second all the way down to 13,000 transactions, about 10% or so drop in performance, purely because I'm accessing the storage across a distance, in this case, 100 kilometers away. So one question always comes up: why does the Vplex perform much better than the Vmax? Right? Because at the end of the day, the Vmax is the back-end storage. Why do I see a difference between just at zero distance, the difference between the performance given by the Vmax array versus that provided by Vplex? Now, Vplex is a caching. It has cache on it, right? It also does read caching. And so anytime there is read caching, and Chad mentioned that in his talk too, is that there is a good chance that we would not have to go actually to the physical storage to get the piece of data that is being asked by the application. And it can be served by the Vplex director's cache itself. So essentially, the director's cache acts as an extension of the cache provided by the storage array. And that gives you a performance benefit. Depends on the workload, but it can certainly help for a lot of the workloads. Now, a DVD type infrastructure, the benchmark that we were using, the DVD store, is a read intensive workload. Right? It's an OLTP workload, which is about 60 to 70% read workload, which means that any read caching that I can do in front of it will obviously benefit the workload that we're seeing. So you can be pretty much assured if your workload is going to be read intensive, which is vast majority of the workloads, putting a Vplex in front of your storage array is more than likely going to give you a performance benefit in addition to all the other benefits that I just talked about. So So that was what was validated. And one other thing that I want to mention is that the VM migration time when I moved it across the 100-kilometer distance was about 90 seconds. Remember, it's 8 gigs of virtual machine at 8 gigs of memory. So moving 8 gigs takes about 90 seconds at the latency of about 5 milliseconds. It's pretty fast, non-disruptive. We never lost connectivity. Any clients didn't lose connectivity to it with no impact, basically no impact. And in addition, we're getting performance benefit of using Vplex in front of the storage. Okay, that was the validation that we were able to do. And this is obviously a summary of numerous numbers of tests that we have run over the months. So that's the first step towards what we are doing. I just quickly want to talk about some of the future directions. So the goal that, as Ravi mentioned in his initial introduction, was that all of the work we have been doing is towards disaster avoidance and workload mobility and load balancing between sites, and we are not addressing the disaster restart part, right? It's still possible that you will lose the primary data center, and then you're stuck with the environment just on the secondary data center or your site B. You have all the data there, but you need to restart all your VMs in that case. It's no longer a plan B motion from site A to site B. To do that, VMware provides this great product called VMware Site Recovery Manager that all of you know. So there is work going on right now to integrate the Site Recovery Manager into the Vplex paradigm so that we can use Recovery Manager in case there is an unplanned event, right? If your site A goes down for any reason, we can bring up all your VMs on site B. In addition to that, there is a lot of work going on working with VMware in integrating VMware DRS and HA so that we can have a single extended cluster being spanned across multiple sites. And also there is, which John alluded to earlier on, there is elastic LAN extension options being worked on, which would improve on the GSS and the ACE technology that we had used for our testing. Okay? And obviously the most important thing which a lot of customers are interested in is that all of the testing we have done is with 100 kilometers in a synchronous fashion. The question always comes up about asynchronous support. That's something that we are working towards, and it's planned for future, which obviously implies that we have to support longer distances, which will be more than 5 millisecond round trip time. Vblock also is undergoing a lot of changes, right? So what we talked about was the current releases of Vblock, and there is obviously a roadmap around later versions of Vblock that we continue to test and plan on. And here's a quick summary of the Vblock roadmap. Obviously, we have Vblock 1 and 2. And 0 out here, we are integrating it so that we can get the newer ones, which is called the Vblock 2000. And here's a quick, I'm not going to read through the slide, but there is certainly a plan that we have all the way out to 2011, 2012, which is committed on what we are going to be doing. In 2010, we'll be coming shortly with Vblock 2000 for the vCloud. And then we have plans for Vblock 2011 for 2011, which would include a number of enhancements. Obviously, these slides are going to be available for you as attendees, so you can take a quick look at it, or you can go to the VCE booth to get more information. So this is what we started the discussion with, right? This is what the current solution looks like, where we are migrating a VM from one Vblock to another Vblock. From data center 1 to data center 2. This is the current state of affairs. We want to go to something which is more towards a vCloud type architecture, where we have a customer data center with a number of physical servers, lots of VM running, all virtualized, your virtualized data center, all protected by a firewall, integrated with a number of service providers, British Telecom, Rackspace. Also, your customer, your data center could also be part of this external cloud. So this is what was called as a hybrid cloud. Remember that in Paul Merritt's keynote? This is a hybrid cloud, and obviously we want to move in that direction. But you can take any VM in your current data center, actually move it to your own data center, or you could move it to any other service provider's data center. And that's the direction that we are working towards. Obviously, to get there, there's a number of steps we'll have to take to get to that point. Okay? So a lot of information available. We touched upon lots of technologies in this talk. And you can get a lot of details, a lot of white papers that you would be able to go to and look at it. And if you have any questions, I think we have about 5 minutes to take some more questions. Do you guys like the question mark? It's a cloud. So. So any of us will take any questions if you have a few minutes. We have about 5 minutes left. Please feel free to ask me any question. Everything looks good? All right. Thank you so much for coming. Appreciate your attendance.